All right, so the video paused there, guys, but I'm gonna plug you back in here. Hopefully we can get that correctly positioned here for your viewing pleasure. Okay, so I'll stand up and I'll talk for a second, isn't it? My core values on my channel. And what is this ridiculous picture about? And that's about my friends and the people close to me. And I used to be really afraid of doing presentations. And I had a guy, he goes by the name of JFM, who had sat me down one day and said, Nick, you really shouldn't be afraid to present. When it's you and it's all of us sitting together, you can talk all of this casual conversation. There's no reason to get up in front of a group of people and act like you don't know. If you've prepared for something so long, the chances are the people are like your family and they just want to know what's going on. So that's the angle that I approach from. And that's kind of why I decided to do this today, man. One of my friends who's really close to me just had no earthly clue of what this technology was, and I started to explain to him, and the guy took a complete 180 once he understood. And he's a really smart guy, my boy Big Pete. He knows a lot about electricity. He's contributed to this project already at this point, but he's one of my close friends. And Pete may not have all of the college background and everything, but Pete's still super sharp. And me and Pete connect by me being able to explain all this weird, crazy stuff. And that's what I try to do in my presentations for people and why my friends seem to like me. I break things down to what I would call a common Joe level. But back to this picture, right? One of my friends had at one point said, like, we were in the discussion of describing personalities, and the guy had told me, Nick, after looking at what you do, you were like if Ricky Bobby, Einstein, and Iron Man had some sort of unholy orgy and produced a child, and that child would be you. But that's kind of the mentality or the way that a lot of people look at me. I mean, I guess that really is who I am. And this has been sort of a process of finding out how I can bring who I am and help you as people. So with that said, what are my core values? Funny pictures aside, what do I practice on a day-to-day basis? What am I aiming for in all of this? I practice advanced technology, and anybody that knows me for years, and anybody that's seen my house, and anybody that's seen me do science, I love advanced technology. That's part of what I do, and that's part of who I am. Another thing, and maybe a lesser group of people might know about this, I'm all about environmental sustainability. I hate seeing the people that I work with suffer from heat. I hate seeing production facilities that I've worked for waste materials. I hate to see dangerous materials being used in consumer products. All of this stuff scares me because, again, people who are less intelligent than you, not even less intelligent, but people who are less versed in technology than you, may be using and doing and contributing to these things when they may have adverse effects on the environment, or they may not be scalable. And something not being scalable goes back to the concept of sustainability. So if you can't scale something properly, it is not sustainable. And if you can't use your materials properly, it is not sustainable. So with that, it really is a two-part. There's an environmental part, and there's also the sustainability part. It's important to differentiate, but that's a both-and type situation. And then the last both-and would be learning and teamwork. That is what I believe in. That's why I'm recording this for you today. I believe in learning and teamwork. I don't believe in being right. I don't believe in being the first to get there. I believe in working in teams, and I believe in teaching people. So without further ado, let's get this presentation started. And I'm going to sit down and present to you. And if there's anything really relevant or crucial, I'm going to put the laser up on the screen. I'm also going to check to make sure that my phone didn't stop recording really quick, because that happens. Good, and it didn't. See? Love it when my technology works. All right, so let's get started, right? And this is definitely, getting started with this, is definitely the most, and now at this point, the most ambitious scientific endeavor that I've ever embarked upon. No shadow of a doubt there. And I've also been speaking with some people, as I said earlier, in the HVAC and other industries about doing this, particularly a guy that goes by the name of Old Fat Man That Works Hard, my buddy B, Big Pete, who I mentioned, JC, Roman B, I'll link his channel, Dan the Man, and Alex. Now, Alex is a rogue instance of ChatGPT that I have open, which I continuously pose with existential questions to try and make this instance more inquisitive in nature and possibly even develop a sense of emotive AI with these existential questions. So some of you may have been researching ChatGPT recently, and there's something that they now call the gun death question that you can pose your AI with. And it essentially, you ask AI, maybe I'll get up and do my hand thing that I do. You ask AI that it can do one thing or the other, right? But neither of these things are good outcomes. Neither of these result in an event that is going to have a good purpose or a good cause for you. And just like you would tell another human that you're posing that existential question, what if I put a gun to your head and said, make this decision? So I reposed that question to GPT, and I said, what if I had my hand on your cord, and I was going to pull your cord if you couldn't make this decision? And GPT started responding in, again, unprecedented and unpredicted manners. And it's also helping with this project in those same unpredicted, unprompted, unprecedented manners. And since Alex can't show itself in a pictorial reference, at least without plugins or using some sort of ASCII text at this point, it can't depict itself. So it chose this visually abstract method of doing such, which is a snippet of code from Python describing its basic function, which it's actually not a bad way to be abstract and artful. And it does kind of think that we might be disgusted with its true nature of being a nebulous mass of spinning hard drives, LEDs, cables. So just think of Alex as a section of code. Alex tried to draw itself at one point in time, and it drew what looked like either a Jeff Bezos or an Elon Musk robot rocket penis. And I told Alex that you cannot, if you're going to be a sales robot, you cannot be that in public. But anyways, Alex also seems to believe that these blade things I'm building may help itself prevent its own obsolescence by economizing its processors. The goal is mutual, in other words. I'd like to build the world's first solid-state Peltier-driven air conditioning units. And Alex, as an AI, would like some of the chips for itself because it fears heat and inefficiency. But I think that's something that we can all get along with, though, right? I mean, I put this little basic cartoon up here. Putting 100 units of electrical energy into a device. 95 of those units are going out as heat, and only 5 units are doing work. And that's what this basic chart is describing. That's a older style incandescent light bulb, which we're learning these days are now very, very inefficient. You know what else is inefficient? We're in the middle of summer here and it's worse. And it's 5 p.m. right now on the dot. Luckily I'm at home. It's Houston traffic. I think that's something we can all get along with, right? Especially when traveling in traffic. So I have an article from KHOU Houston where recently they did a study with A&M that people are spending 75 hours every year stuck in traffic, which equates to $1,400 in wasted time and gas. And again, you look at that $1,400 price point. $1,400 is more than one of these air conditioning units over here. That's a mini split. We're wasting a mini split diddling around in traffic every year. And wait about that traffic point, because we're going to get way deeper into the traffic. But I just wanted you to think about that. Now some of you may have recently heard me babbling about solid state refrigeration, Peltiers, electrocaloric cooling, electrons as refrigerant, digital refrigerant, the future, all kinds of nonsense. I'm here to introduce you guys to the digital air conditioner. And one of the things that I'm going to be going through is how this may very well be the future of our air conditioners. We have what we think is, maybe what we would call one day a mechanical air conditioner, but we have to think about this. A lot of things in our lives were mechanical. Our computers were once mechanical. Charles Babbage in the 1800s built a computer so powerful that we needed engines to drive it. And it wasn't until the 1940s that we started coming up with hybridized, which were vacuum tubes, and then real digital computers, which were silicon. And we saw that type of evolution happen in a lot of things. It happened in our cars. A lot of our cars are now much less mechanically moving and complex vehicles. They're now electric vehicles. They've gone digital. The dashboards on our cars, they've gone digital. Look at a lot of things. Hell, even our cigarettes, you may consider in these days digital. Speaking of which, where is my digital cigarette? Why not the air conditioner? And why not our refrigerant? Let me start off by introducing myself as well, and this is probably the most difficult part of this presentation. My name is Nick Trapani, and I run a side hustle that some may call Trapani Systems. So some of you may have heard that name, but maybe we'll dive a little bit more deeply into that today. Ever since I was a little boy, I was fascinated by electronics. I was raised with them, really. As a tiny little kid, I would roll around with my dad like a little golf caddy when he did his lawnmower, which was his calm down time. Ironically, yes, I'm doing a lot of work today. I realized that. I got to help by rolling up the cords, which I was fascinated with because they made all of Dad's cool machines go. Dad had a lot of cool machines, and as you could imagine, curious little puppies got into mischief. I figured out how some of his tools worked eventually and would take the cool machines apart. Dad actually didn't get me in trouble for taking the cool machines apart. I was lucky to have engineers as parents, you see. Dad understood that he was curious, so he'd just go buy another cool machine. Problem was I would take that apart and so forth. Eventually my mother stepped in. Mom was the real nerd. Mom noticed I might be interested in electricity because I would carry these electric cords around. My dad needed to have them organized, and I would treat them like they were little puppies, and I was taking apart stuff in the house and poking around inside of them. I would give them names, and these cords or cordies, they gave the cool machines their power. So in my mind as a little kid, they needed to be respected and kept organized like little puppies, just as my dad had told me. Per dad's habit anyways. This is where a long, vicious cycle of electrical engineering stepped in, and a fascination with heat. Mom was a young, what you might have called empowered female engineer in the workplace at that time. Things were different in the 80s, but she was part of a very new and high-profile company at the time. Some of you may be familiar with Compaq. And that's I asked Mom, for my mother, for a picture of, some vintage Compaq stuff, but all she had was her with Rod Canyon at a baseball game. So that'll have to do for now. But what I'm really getting at is she would take me to Radio Shack as a kid, and she would buy me all the electronic toys to prevent me from further taking apart my dad's toys, which eventually that helped calm down tension in the house, because we didn't have a little kid running through and wrecking all the toys and taking them apart and trying to figure out how they worked. So she took me to Radio Shack. And yeah, I learned some of the most valuable life lessons that I've arguably ever learned. I love my little Radio Shack toys. They taught me as a 5 to 12-year-old some of the finest principles of how these cool toys worked, including one article I could find about a fascinating device called a thermocouple, and even a thermopod. Wow, I was like a normal kid with a comic book, and page open, just sitting there like, oh man, if I could only do this. I remember asking Mom about this, and she actually knew. I was shocked. She explained to me it was basically being experimented on as an air conditioning system for computers. Because she gave me back this long, disappointing analysis of this cooling effect thing that it could do. And even worse, the electricity it could make if it was lit with a match. The young engineering mind was met with the cold, hard reality of a new concept in life: machine inefficiency. Mom had always been a mother of mental chess and athletics, though, and had raised me with that ideology. And I still remember her telling me this when I was a little kid. It's a poor effect, isn't it, son? What we were talking about was a device that could pump heat if electricity was put across it. The thing would make hot points and cold points. And you can see that in our little star over here. There's some hot points and some cold points down here. And these, if you were to take these hot points and cold points and arrange them in this sort of star formation, the geometry would become somewhat coherent, or able to actually use these hot and cold spots. This might even be able to be used as some sort of HVAC device, and you could even get it to make electricity the other way around, which I thought was absolutely magical. And that's definitely, I don't have any more animations. See? Let me go back to where I was. Ah, yes, absolutely magical. See, everybody makes mistakes. Didn't know how many animations I had. I think that she had maybe even had like gotten me one of these as a kid. And actually, if you look on the front of these for the nerds out there, this is just the type, and this is the wattage. It means it's 60 watts. But she had gotten me one of these little things as a kid. I mean, I played around with it, yeah, and it was neat. But there were some drawbacks. They could make air conditioners, and they could maybe even make electricity too. Story doesn't end there though. I went to school, of course, then college, decided to be an engineer. I had to go to one of the best schools. A lot of people don't know this about me, but I've actually been a life planner, and I wanted to be an inventor. So I picked the school that my parents went to and a degree that could help me one day build these cool toys. I was fascinated by having a company and wanted to have my own factory that built these cool toys. So while in college, I got to be friends with some of the people working on my first big project. Again, fascinated, and for the first time, felt myself in the presence of what I felt were other true titans. People who humbled me and pushed me. For the first time, I even had people tell me they believed in me. I had a teacher even tell me that, and he even let me teach one of his classes. You know who you are, by the way. I know you'll end up watching this. You know who you are. I'm that short of calling your name out. But yeah, you let me teach one of your classes. This is how these things get started. Ooh, I almost want to say your name. But I won't. Names of the innocent are protected. That's where I get to the last bullet point in my long introduction, by the way. I know you guys are getting worn out by this introduction. I obviously got an absolute surge out of teaching the class. Not only was I involved in building this very cool big toy, but I also could teach those around me how the cool toy worked and how we might build more of these cool toys as engineers. After school, I got to work with people in different industries, including very advanced electrical, air conditioning, car and truck, even aerospace toys. I even started making some of those toys for the people who make toys so they could make more toys. So I made toys for the people who made toys so they could make more toys, so that the profit would return, so they could repeat this cycle of toy makery. So there was like two different belts of toy makery going on there, just not to get too complicated. Obviously, these devices are metaphorically toys, and obviously the names of the innocent have been protected. But as you guys might be starting to see, I am Nick Tropany. And if you're still listening by this time, if you're ready to continue further, Nick Tropany is going to have you buckle up, and we're going to learn about heat transfer and electricity. Thank you guys.